Welcome to the solutions to the Regents Physics Electromagnetism problem set. Problems numbers 2, 6, 8, and 9. Number 2, a current carrying wire runs across a laboratory bench. Describe, if you have a compass, at least 2 ways you could find the direction of the current. Well, first you could use a compass and the appropriate hand rule to determine the direction of the current flow. You would do this by placing the compass above and then below the current carrying wire to determine which direction the magnetic field is traveling around the wire, and then use the hand rule where your fingers curl in the direction of the magnetic field and your thumb points in the direction of the current flow. You would use your right hand for conventional current, and you would use your left hand for electron flow. Ask in class if you don't understand this and would like to see it drawn and labeled on the board. Second, you could bring a magnet of known polarity near the wire and observe the resulting force on the wire. Using the appropriate hand rule, determine the direction of the current flow. So the current carrying wire creates a magnetic field. If you bring, say, a bar magnet where you know the North Pole, which end the North Pole of the bar magnet is, if you bring it near it, the bar magnet is either going to be attracted to or repelled by the magnetism created above or below, or in front or behind the current carrying wire. So by knowing the polarity of the bar magnet, you can figure out the direction of the magnetic field. You will know the direction of the force on the wire due to the magnetic field. By knowing the force and the direction of the magnetic field itself, you would be able to use the hand rule to determine the direction of the current. Again, if you don't understand either one of these, make sure you ask, and I'll show you on the board in class tomorrow. Okay, next, number 6. Earth's magnetic field lines are shown in the diagram below. At what location, poles or equator, is the magnetic field strength the greatest? Explain. Well, magnetic field is always strongest where the lines of force are closest together. And this, of course, would be at the poles. Okay, so the strength of the magnetic field is strongest at the magnetic poles of the Earth because that's where the lines of force are most concentrated, closest together. This is true of any field. It's true back when we studied electric fields. Electric fields are strongest where the electric field lines are closest together. Well, magnetic fields are going to be strongest where magnetic field lines are closest together. Study the diagram that's included here carefully. If there's something bothering you about this diagram, ask when you're offered the opportunity to do so in class tomorrow. Number 8, a conventional current is in a wire as shown in the diagram below. Sketch the magnetic field that the current generates. Well, conventional current flows away from the positive towards the negative, as opposed to electron flow, which goes away from the negative towards the positive. So, conventional current tells us that we need to use our right hand. We point our thumb into the page because the artist is trying to depict that the current is flowing in the wire into the page. Our fingers curl in the direction of the magnetic field around the wire. So that would be a magnetic field that's in the shape of a cylinder around the wire. And because our thumb points to into the page, our fingers are curling clockwise around the wire for the direction of the magnetic field. And number 9. The current is coming straight out of the page in the diagram below. Sketch the magnetic field that the current generates. Again, if this is conventional current, using the appropriate hand rule, you'd take your thumb and point it out of the page on your right hand. Your fingers curl in the direction of the magnetic field around the wire. So it should look something like this. With our thumb pointed out of the page, our fingers curl in this direction, which is counterclockwise around the wire. Alright, that'll do it for our selected problems here. Numbers 2, 6, 8, and 9. More to come on the magnetism concepts that you studied tonight when we do problem 4 in class together tomorrow.